Guys, so in the previous video we had a look at proving these two trigonometric identities. In this video we are going to look at simplifying trigonometric expressions using them. So I'm not quite sure how many questions we're going to do. I'm making this up as I go, but if I were you, pause the video at each one, have a go yourself. So the idea is you play around with whatever you've got and just to see what you can do with it. So, first up, we want to simplify cos of theta times tan of theta. So, which of our identities are we using here? Well, we've got a tan. So it's going to help to turn tan of theta into sine of theta over cos of theta. So, we've got cos of theta times sine of theta over cos of theta. So we've got a common factor of cos of theta, so this is actually just sine of theta. There we go, simplified, we've done it. Okay, example 2, sine of theta divided by tan of theta. So, again, tan of theta is sine theta over cos of theta. So we've got sine of theta divided by sine theta over cos of theta. Again, when you divide by a fraction, you flip it over and multiply by it. So this is sine of theta times cos of theta over sine of theta. So this actually just gives us cos theta. Nothing else we can do there. Jobs again. Example 3. Tan of theta plus 1 times tan of theta minus 1. So, what can we do with this? Well, first of all, first thing to notice, it's a difference of 2 squares. So, if we were to multiply this, we would get tan squared of theta minus 1. Now, tan squared of theta is sine squared theta over cos squared theta. So we got sine squared over cos squared minus 1. Now, then can we manipulate that at all to write it in terms of just sine squared or cos squared? Well, let's first of all turn it into a single fraction and see what we can do. So we could write this as sine squared theta over cos squared theta minus cos squared theta over cos squared theta. So that fraction there is just 1. Cos squared divided by cos squared is just 1. So what I'm going for here is common denominators. So I could then write this as sine squared theta minus cos squared theta all over cos squared theta. Now we've got more cos squareds kicking around, so let's turn this into a purely cos squared expression. So, if we know, we're going to need one of our identities here. So we know sine squared theta plus cos squared theta is equal to 1. Then if we want to turn sine squared into something to do with cos squared, we would take away cos squared of theta and we would get sine squared theta is 1 minus cos squared theta. So, if we substitute that into sine squared theta minus cos squared theta over cos squared theta, we will get 1 minus cos squared theta minus cos squared theta all over cos squared theta. Now we can simplify that as 1 minus 2 cos squared theta all over cos squared theta. Now we can split that up into 1 over cos squared theta minus 2 cos squared theta over cos squared theta, which finally simplifies to 1 over cos squared theta minus 2. Good times. Okay, so you might not need that many steps, but remember, I'm trying to make things as clear as possible. Next up, we want to write cos squared theta in terms of sine theta. So not sine squared theta, sine theta. So given that we've got a cos squared, we are going to need sine squared theta plus cos squared theta is equal to 1. So if we rearrange that to get cos squared on its own, we get cos squared theta is 1 minus sine squared theta. So at the moment we have got cos squared theta in terms of sine squared theta, but we want it in terms of sine theta. So on the right we have a difference of two squares. One is a square number, sine squared theta is a square number, and we've got a subtraction. So we have a difference of two squares. So we can actually factorise the right hand side to get cos squared theta is 1 plus sine theta times 1 minus sine theta. So there is cos squared theta in terms of sine theta. Good times. Okay, next up, 1 over tan theta plus tan of theta. So surprisingly, the identity we want to use here is tan of theta is sine of theta over cos of theta. So 1 over tan of theta is going to be cos theta over sine of theta. So we got cos theta over sine of theta plus sine of theta over cos of theta. Now to add together fractions like that, I would use the cross multiplication method. So I would do bottom of the second times top of the first. So cos squared theta plus bottom of the first times top of the second, sine times sine, sine squared theta, and then that's all over the two bottoms multiplied together. So sine theta cos theta. So up on top, cos squared theta plus sine squared theta is exactly the same as sine squared theta plus cos squared theta. So we've got 1 over sine theta cos theta. Nothing else we can do with that one. Job's a good one. Okay, next up, we've got a beautiful specimen of an exam type question. So, given that 4 tan theta sine theta equals 4 minus cos theta, we want to show that 3 cos squared theta plus 4 cos theta minus 4 is equal to 0. So, basically turn everything in this first equation into cos's and then into the form that we have at the end here. So, 4 tan theta sine of theta. Well, again, tan of theta is sine of theta over cos of theta. So, we are going to rewrite this as 4 sine theta over cos theta times sine of theta, and then we've got that is equal to 4 minus cos theta, like that. Okay, so that's eliminated tan from proceedings. So, now on the left hand side, we have 4 sine theta over cos theta. So we can say that's 4 sine squared theta over cos of theta. And that is equal to 4 minus cos theta. I think my next move would be to get rid of this cos theta so we don't have any fractions. So we then got 4 sine squared theta is equal to 4 cos theta minus cos squared theta. Now we're going to want to turn sine squared of theta into something to do with cos squared theta. So remember, sine squared theta plus cos squared theta is equal to 1. So sine squared theta is 1 minus cos squared theta. So we've now got 4 lots of 1 minus cos squared theta on the left is equal to 4 cos theta minus cos squared of theta. So now everything is in terms of cos, so that makes us happy. I forgot to change back to blue, my bad. Okay, so if we expand all this out, we've got 4 minus 4 cos squared theta is equal to 4 cos theta minus cos squared theta. So now it's just a case of getting everything on the same side. Now let's just check what we wanted. So we wanted to have positive 3 cos squared theta. So we are going to want to move everything from the left hand side to the right hand side. So we're going to add 4 cos squared theta. So we're going to have 4 is equal to 4 cos theta. And then, minus cos squared theta, add 4 cos squared theta is positive 3 cos squared theta, and then we're just subtracting that 4. So we get finally 0 is equal to 3 cos squared theta plus 4 cos theta minus 4, which is exactly what we were trying to prove. Marketing QED and a smiley face. Good times. Okay, that seems like a good place to leave this one. So, hope you found it useful. If you want more, let me know down below in the comments. Next up, we're looking at trig identities when we know certain angles. Or, for example, we're told sine of theta is equal to 2/3, find cos of theta. Things like that. See you then.